have the final section of Chapter 2, and we're going to be dealing with algebraic proofs. Now, an algebraic proof is a list of algebraic steps to solve a problem. You've been doing this for a long time, but now we're just going to make sure we know what gives us the right to do certain steps. And here are the properties that we're looking at. And most of them just make a lot of sense. Addition property, okay? If you have two numbers, you can add a third number to both of them, okay? Not a big deal. Subtraction property, same thing. You start with two numbers that are equal, you subtract the same amount from both sides. Multiplication, same thing. Start with two numbers, you multiply by a third number. You're good. And division property, start with two numbers and C not equal to 0 just because we all know that you cannot divide by 0. So whatever other number, if you divide both sides by the same thing, you'll still be an equal statement. Reflexive property, I call this no duh. Okay. A equals A, no duh. Okay. Symmetric property, if A equals B, then B equals A. Again, that's a no duh. Okay, you can flip them. Transitive property, this is a cool one. I think of a train here. If A equals B, if that car is connected to this car, then these two are connected also. Okay, A equals B and B equals C, therefore we know the two outside ones, AC, are also equal or connected. Substitution, that's like in volleyball where you just one girl goes in for another girl, they hold hands for a little bit, they giggle, and then they switch spots. The one who was on the bench takes the spot of the girl who is on the court, or was on the court, takes her spot. So if A equals B, you can replace it. A can be replaced by B in any equation or expression. And distributive, y'all have seen this for a while. If A is B multiplied times B plus C, or this could be a minus also, then A times B, the outside number times the first number, plus comes along for the ride, and then A times C in the second part. Okay, so now we're going to look at some different types of real life scenarios, or I shouldn't say real life, but where we have numbers and stuff instead of just those old boring letters. Okay, if the measure of angle 1 equals the measure of angle 2, then the measure of angle 2 equals measure of angle 1. I talked about that. That's a no duh. It's up here at the symmetric property. Okay, if A equals B, then B equals A. You just switch them. Okay, if the measure of angle 1 equals 90, and the measure of angle 2 is equal to the measure of angle 1, then measure of angle 2 equals 90 degrees. That's transitive. Suppose you can also call it substitution. Okay, that's why I have that both written down. But transitive is really the one I think that makes most sense. C, a lot like B there, if AB equals RS and RS equals WY, then the first one and the last one equal each other. Again, transitive property. If AB equals CD, then 1/2 AB equals 1/2 CD. That's really multiplication, but I can see where some people might put division because times 1/2 is the same as dividing by 2. E, if the measure of angle 1 plus the measure of angle 2 equals 110, and angle 2 is equal to, the measure of angle 2 is equal to measure of angle 3, then we can just go ahead and put 3 in for 2. See where this 2 was here before, but now 3 is there. We substitute it in, equals 110. So RS equals RS, that's the no duh, reflexive. And if AB equals RS, and TU equals WY. Okay, so we got two pairs that are equal to each other. We can add one of one and one of the other and say they're equal to one of the first and one of the second and the other one. Okay, that's addition property. Okay, we're adding the same to both sides of the equation. And then another example here of transitive, if measure of angle 1 equals measure of angle 2, and angle 2 equals angle 3, then 1 equals 3. Again, you could use substitution kind of the same way. Now we're going to have some proofs. Okay, so we've got this proof here. It's given with this start of the equation. 4x plus 6, the whole thing divided by 2 equals 9, and then prove that x equals 3. Okay, so, oops, dang it, I forgot to divide it by 2 in there on my original problem there. Forgive me, please. Okay, but you always write down whatever you started with and you write given. Then you start doing the math. In this case, I needed to multiply both sides by 2 to get rid of my denominator. So when I did that, I get my 4x plus 6. I'm still left with my numerator, but now I get an 18 because I take 9 times 2. That was multiplication property. And obviously you can abbreviate like I have done here. I did it because otherwise this stuff runs into the next proof and I want that. Okay, and then I can take my 6. It says plus 6. I'm going to subtract 6 from both sides. That's how you get subtraction property. So I get 18 minus 6 is 12, so 4x equals 12. And then my last step, of course, I am going to divide here. So I get x equals 3 because I divided both sides by 4, and I get the division property. Going to our second proof over here, we've got this given to us. We're going to prove this. So we write down our given, and number one reason is always given. Now I see, you know what, I got to get my x's together. So I need to take this x over here. Well, I don't just take it over there. I got to subtract x from both sides. 4x minus x is 3x. Again, I write down the plus 8 and the 2. Now I've got to get this 8 over there. Now it kind of stinks that I'm going to subtract 8 and I'm going to end up with a negative, but that's okay. It comes out in the wash at the end. Okay, I'm going to subtract 8 from both sides. That's why I get subtraction. I'm sorry, I got subtraction the first time. I get subtraction again. When I subtract the 8, I get negative 6, so I get subtraction the second time also. And then I divide by the 3, so that's where I get the division property. And when I divide by 3, I just get x, which of course is what I want. The negative 6 divided by 3 is 2. You have just seen your first two proofs. Talk to you later.